I'm outside very much on purpose, and it's windy out. And there's a lot of stuff going on. And the reason that I'm outside with it being so windy and so many things going on is because we're talking about sound. And the way sound works is really all it is vibrations that happen, and that's energy and kinetic energy, and that energy moves the particles that are in the air, and it moves them in a certain way that they kind of form these waves. And when these waves and these vibrations, they kind of pass along to each other, when those waves eventually reach something like our ears have been, over a long period of time, been able to be, not just us, but for living things over a long period of time, been able to figure out what those waves were, turn them into electrical impulses, sort of, and then it works into our brains. Microphones work in a similar way. The waves, the vibrations go into the microphone, it turns them into electrical impulses, and then those impulses are translated into, like in this iPad, into what we would consider sound. Amplifiers the same way, anything with music. I'm outside on purpose because there's a lot of sounds going on in here. If you can hear in the background, there are birds chirping, and there were some grackles yelling at me a little bit ago. There's the wind blowing in this chair that I'm in, this rocker. It's not as loud right now, but it was super loud before. And there's cars in the background, which is at the interstate. There's things going on. You can kind of hear the water down below. There are so many sounds and so many vibrations going on that that's hard to pick out. But with sounds, they're fancy. So this is a tuning fork, and tuning forks are actually used to tune pianos. So they have a certain tone that they would have, and it has a specific, they design it so that it gives a specific wavelength, which is a fancy term for how often the waves go up and down. We'll see that in one of the videos today. They'll talk about it in all the videos. But when I hit it, it's going to vibrate, and those vibrations make the particles around go up and down, and move, and it kind of goes out until it catches it in my ear. Anybody else that might hear it missed, and they continue. So I'll put that down on my microphone. Now, different sizes of these will make different sounds. So this one's a little bit higher sound. And the higher you get, that means the closer the vibrations are to each other, and they're going to call that a wavelength. And let's see if I can get this is a pretty low one. This is another one. So those vibrations are really low. So the different tuning forks, depending on the size, they set them up. They'll tune it, and this will be a C. You can use it for a piano, the different notes. And the notes are going to categorize. This is an E, and it's going to be one step up from the E. But then I have a whole set of these, the tuning forks. And had we been in school, we would have played with them a little bit, but you'd have to be careful. We can't be so rough on them. But I want to show you a little bit about how the waves work, kind of simplify it. 3 videos. They shouldn't be too bad. And then just a couple of questions, but not as easy as the last one, but still not too hard. This is my tuning fork, and as I showed you before, the tuning fork, if you smack it, it's going to vibrate. It's back and forth. You can feel it, like, ooh. So it's vibrating, and it's causing some of these vibrations are going to disrupt the air, and they'll send it out out and out and out, and eventually end up with the ear, in somebody's ear to hear it. Question is that there's this silly philosophical type question is, if a tree fell in the forest, does anybody hear it? Or actually, if a tree falls in a forest, and there's nobody around, does it make a sound? Well, the vibrations are there. A lot depends on what you consider a sound or not. Is it having somebody hear it? Is it having somebody do the impulses? No. But are they making the vibrations? Oh, yeah. Now, the different ones, this vibration is a little bit higher than the other ones, which I showed you before. And it's a lot higher than this one. And the difference between the higher one and the lower one is it's the amount of space between like these vibrations. So these vibrations come off, they actually come off like this. So if you listen very carefully to that, you can kind of hear the woo. It's hard, you'd have to really hear very closely on it. If this is the faster one, this is the higher one. And the other one, the wave is moving at a slower speed. To us, that's going to sound like a lower note. So if this one is this, this one then would be this, because it's going to be, the wave is going to be lower. And they call a wavelength is how they measure these things. Wavelength is going to be actually from right here to here. So that would be one wavelength. And they have these wavelengths. You can find out exactly what each tone works like. Weird thing, light, same thing. Except for it doesn't have to go through molecules or particles in the air to get there, but it is waves just like this. But they're really, really close together. And some different colors of light, the waves are, some are closer together, some are a little bit farther apart. It gives you the different colors. And then if you put them really close together, you can get like ultraviolet light, which UV rays, that can cause sunburn and not so great for our skin. That's why we have UVA and UVB sunscreen. Infrared, which is heat, that's a little bit wider wavelength. Then we get into X-rays. There's gamma rays that are super small wavelength. Visible light becomes a little bit longer. So, big question that happens. There's a movie. It's called Aliens. In space, they can't hear you scream. Or in space, nobody can hear you scream. It's true. Sound is not going to work unless there's particles that get vibrating. And it's just that whole kinetic energy, just like the particles, when they speed up with heat, these are speeding up. If this is vibrating and there's nothing to vibrate, no particles around, no sound. It's not going anywhere. Kind of like our thermos, when there weren't any particles in between the parts, heat couldn't go to them, speed them up, and then those ones couldn't speed up anything else. So kind of all comes down to that same thing about if there's something there, the particles, we can give them energy, make them move, sound. Particles, give them energy, speed them up, they become warmer. Within the waves, they measure them by how many of these waves go through in a second, and that's called a hertz. So however many waves go through in a second is a hertz. So if it goes 16 waves in a hertz, that's about the lowest that we can hear with our ears. So somewhere between 16 and 32 hertz are the low end of what we can hear. 32 hertz, that's the bottom of the piano. That's the bottom note of the piano. And if we go to the middle, and I had showed you this one before, it's middle C, it's dead center in the piano, so this middle C, this is the sound that you hear, and this sound is going 253 of these waves every second. So 253 waves go every second, that's 256, that is 256 hertz. We can go up higher with the smaller tuning forks, and the waves are going to be closer together. And we can get pretty close to, like with our voice, I guess it's going to be in the 10 to 12,000 range for hertz. So 10 to 12,000 of those cycles a second, or the waves each second. Our hearing itself is a human hearing somewhere between 18, 20,000. You can do a test and just Google the sound frequency test, and it'll give you some sounds, and you can see if you can hear them or not. You have to be, once they get really up there, it's hard to tell if you can hear them or not. But some of the kids in class, somewhere we were around 22,000, maybe 23,000 hertz that they could hear. I'm not sure if they really heard it or if you kind of think you hear it, because it's really a faint sound. But for me, mine ends somewhere just below 16,000 hertz. And the reason for that is as you age and as your ears take in a lot more sounds, they become damaged, and that's just normal. Wear and tear on the body, and right around my age too, you just can't hear the high frequency noises. There are other sounds that you can have, and I didn't show this one before, but this, my mother got this for me, and she told us on my birthday a while ago. She told me that this is a calming sound. So the vibrations, they're going to hit here, and they're going to make some vibrations. And it's supposed to be out in the wind. And I'm not sure what she was talking about with the calming sound, but it is kind of cool. 3 videos. Watch them. Then 3 questions. Answer them. See you later.